Okay, I'm going to open up the Powerlogger software so we can look at a log and step through what it takes to look at the VE table and make changes to the VE table. So I'm going to load up a log. This is a drive that I did, about a 15-minute drive. And I usually start by going to the graph tab, and usually we want to look at RPM and map, the wideband, and the correction, the fuel correction. So now we can kind of scroll through a whole run, and we can kind of see what the correction is doing down here at various times of the run. Here's a section here where I was at full throttle, I believe. Let me change just the throttle position. Yeah, you can see where I was at full throttle up here. And if we want to look where we're at in the VE table, we press the Tune button, click VE, and then when we click on the Graph tab over here and move back and forth, I'm holding down the left mouse button by going back and forth. You can see there's a floating bubble that appears over here and tells us right where we're at any given time during this run. So by having this information, it can help us decide what parts of the table might need a little touching up so that we can reduce the amount of correction that the program needs to apply. If I look at this run, if I back up into this area, for example, you can see the correction is at minus 10%, which is the low limit. So it's pulling out all the fuel it can. The target was 13.5, and the actual is 12.7. It pulled out all it could, and it still couldn't pull enough to bring it all the way to 13.5. So if I kind of move back and forth over this area, I can kind of see that the bubble is hanging out in this section of the table. And since that's at minus 10, that basically means that this area of the table needs to be reduced by 10%. Now by 10%, it doesn't mean you just subtract 10 numbers off of any of these cells. It means you need to subtract 10% of the number that's there. So for example, 70, 10% of 70 is 7. So you'd have to subtract 7 numbers from that. So don't get confused by the 10%. It needs to be 10% of the number that's in that cell. So in this case, we might want to remove 7 numbers from all 4 of these cells. When the program is looking up VE, it doesn't only look at one cell in particular. It looks at the closest cell it's at, and it might have some influence from the cells that are around it. So you don't just want to change one cell. You would change the cell that's closest to the bubble the most, and then cells that are close to it you might want to reduce just a little bit, and it should all be blended in fairly well. So in this case, if this part of the log, if we want to lean that whole area out, we would do like what I just said, go to this part of the table and reduce all the numbers, and you might tweak some of the cells around it so that it blends in nicely. If we move into this area here where I was at full throttle, we can see the correction here was up at 8%. Now, one thing to realize is that the correction doesn't always mean that right on that exact instant is where you need to make the changes to the VE table. The correction here is a result of what has happened, a little bit before that. And so you need to look at what's happening over here as you scroll back and forth across over this section here. This is basically the spool up section where the boost was coming up. And you can see that the bubble moves kind of in this direction here. And so you wouldn't want to just change only right here. You want to kind of back up and see that there's kind of a lean area here. And So all across in here, you might need to add some fuel. I say fuel. What I mean is add VE numbers, and that should help richen that up so that it's closer to its target. Um, you can see again here the target was 11.7, but we were only getting to 12.9, so it's a little on the lean side. So we would need to add some numbers in this area here. And again, you'd want to blend it in. In general, when you get over 100 kPa, most of those numbers are going to be the same all the way up. There are situations that may change, but for now, you would basically want to change, like for example, this row here at 100 kPa and higher boost level. You'd probably want to change that entire column, and then blend it in, around it. Okay, I've moved to another section of the log, and this is where the car was idling at. And in this section, if you go back to the data page, I can look at the park neutral switch, and I can see that it's off. So the car is in drive right now. And so I came to a stop, and the car was in drive, and then I shifted to park right here, and then it stabilized, and we ended up here in park. So this section was in drive, and over here was in park. Now, if you're wondering why I had the car idling in the 11s, it's because I had great big 220-pound injectors in there, and I was working on a tune for these. It's not fully tuned right now, but I'm just trying to show you the difference between park and drive idle tuning, because it's very different. Idle isn't just idle, because in this section here, you can see that the car was idling in the 40 to 45 kPa range when it was in drive, and then when you shifted to park, you ended up over here and it's idling in the 30 to 35 kPa range. And so this is how you tune idle. You can go back and forth between park and drive and see what the correction is doing, and tune these cells separately when you're between your own drive and park. So and that way you can get a good transition between when you're shifting from park to drive, and have the same air fuel ratio between the two. So I think that covers it for now. Let me know if you have any questions on the stuff, and we'll go from there.